Okay, yeah, my name is Maria, and I'm going to talk to you about robots and why I'm thankful for them. Okay, so how do we use robots? We have a bunch of uses for them in our life. Like they're industrial robots that put together and build things like cars or whatever and like other things. And then there are meal delivery robots. And then maybe Internet of Things, like your toilet can be a robot if you wanted to. So what does it take to make a robot work? There are a lot of pieces that you have to put together to make it do things like understand where it is and kind of like move around. And you have to kind of get all of them working and get all of them working together. So localization is a pretty important one. That tells you where you are in the world. So you use like sensors or you use GPS. GPS is not very good for this, by the way. It's off by at least a few meters. Pose estimation is also important. This is telling you how your robot is oriented. So like which way it's facing, if you have like a robot arm, if it's how it's oriented, which way it's turned, stuff like that. Perception. This is processing sensor data. So like you look at an image, it's an example of a pixelated image that in 3D. So it's like a robot is trying to make sense of what is seen. Prediction is how you expect the world to evolve over time. So depending on assumptions you make, it might include like you do something and how you expect the world to change based on that. Planning, that's deciding where you are and like you know where you are and now that you know how you're oriented and stuff and what's happening in the world, what action you're going to take. And last but not least, controls. Given an action or a trajectory, what you're going to do. So this is an example of a balancing robot where controls are really important because you have to react really fast in order to be able to balance. And this brings us to examples, real-life examples. This is the Dartboard Ground Challenge. The motorcycle there is called Ghost Rider. This was in 2004, and that's how it did. That's pretty much the extent of it. So what went wrong? Like, if you guys can guess what went wrong. In this case, controls. It was supposed to be going fast enough to be able to balance, and controls didn't appropriately adjust for that, and it fell over. So they went back, and next year, in 2005, they tried again. This is, again, Ghost Rider. It did a little better with the balancing, but as you can see, it runs into a sign. So what went wrong in this one? Localization and perception. Localization meaning that it wasn't sure where it was in the world. It probably thought it was in the right place, and it clearly wasn't in the right place. And perception meaning it couldn't see that there was a sign in front of it, and it just went right into it. So I have a bit of a personal experience. I tried to participate in SparkFun ABC, which is an autonomous vehicle competition where you make like a car that drives a course. There's no image or video because I did not even compete. That's because I ran into some problems the night before where system integration went wrong. So I found out that my boards couldn't talk to each other. And this is why it's important to do integration tests. So another example. Clearly, it doesn't quite do what it was meant to do. So what do you think went wrong here? Pose estimation. If you recall, the pose estimation tells you how your robot is oriented. So clearly, it thought it was oriented in one direction. It was actually oriented in the opposite direction. And this example is a robot playing tic-tac-toe, and it decides where to place an X. So if you think about what went wrong here, I would say planning, because planning is what takes care of that, but you could also argue that the robot was trying to cheat, so that was actually well planned. And for the last example, I will let you guys analyze what went wrong in this one. Here's a drone cutting hair. And so after all of this, why am I thankful for robots? Well, the truth is that programming robots is really hard. And if if I work on this, I'm going to be employed for the rest of my life, probably.